Hi, my name is Kit. This video will help you ace the chapter of turning effective forces, and I will also be showing you the hidden force that many students tend to miss when they attempt these questions. Let's get straight to the question, and perhaps you can pause the video right now and attempt the question before continuing to watch the video. Well, I hope you have attempted the question, and for those who need a little bit of help, well, let's get right to it. So let's try to extract the information from the question. So we have a uniform rod XY of length 1 meter, and the weight of the rod is 10 Newton, and the rod is hinged to the wall at X. So let's just put the hinge right here. I'm going to just put in annotate. Alright, so the hinge is right there. We'll just put hinge. Okay, and what else is important? So let's try to make sense of what the question has given. So uniform, right? So uniform rod means that the center of gravity of the rod is at the midpoint. Okay, center of gravity of the rod is at the midpoint, and it is right here. So that's where we're going to draw the weight from. So the weight of the rod is 10 Newton, and which tells you that the perpendicular distance between the weight and the hinge is 0.5 meters. Okay. Secondly, we're going to deal with the key concept of this question, that we're going to apply the key concept, which is equilibrium. So we know that the rod is in equilibrium. Now, how do we know that? Because the rod is held horizontal. So for the rod to be able to be held horizontal, the rod must be in equilibrium. So let's take a step back. What exactly is equilibrium? Equilibrium means that, number one, the sum of clockwise moment must be equal to the sum of anti-clockwise moment about the same pivot. So in this case, the hinge would be the pivot. Okay, and for the rod to be in equilibrium, the forces acting on the rod must also be balanced. So that we'll be tackling in the next part. Okay, so anything else we need to know? Right, so we have a value of P that we need to calculate. So what exactly is that? So that's actually the force exerted at Y. So because it's the unknown, normally I will put a label to it. So let me just put an FP over here. And FP is 1 meter away from the pivot. So the perpendicular distance is 1 meter between FP and the hinge. Right, so now let's try to apply the principle of moments, which means the sum of clockwise moment equals to the sum of anti-clockwise moment. So we're going to write this down first, so it's always useful. So sum of clockwise moment, so it can be depending on how many forces that we have. So to kind of keep things simple, I chose a question with only 2 forces. So we need to find out the direction of the moment produced by the forces. So let's take a look at the weight of the rod. So just imagine, if it's only the weight of the rod, then it will cause the rod to rotate clockwise. Right? Therefore, the weight of the rod will produce a clockwise moment. So we're going to write it in here. So clockwise moment. To calculate clockwise moment, just in case you've forgotten, I put the formula right over here on the right side. So we take the force multiplied by the perpendicular distance between the force and the pivot. That would be 0.5 meters. So sometimes I like to put the unit there. Alright, and let's take a look at the other force that we have, which is force P. Now force P, imagine, if it's just the force P, then it will cause the rod to rotate anti-clockwise. So force P produces anti-clockwise moment, so that will be Fp multiplied by 1 meter. Okay, so now we're able to calculate the value of P, which is the force itself, force at P, and that would be 10 times 0.5 meters, and we have 5 Newton. Okay, well, I hope this is useful, and there is a hidden force, and that will be addressed in part B, so keep watching. Here you go. Right, so the next part, we're going to have to calculate the force exerted by the hinge on the rod. And many times when this question appears, my student will say, what? There's a force at the hinge? Okay, there is a force at the hinge. So, because this particular force, be it acting in any direction, it could be like this, or it could be like this, or upwards, downwards. Well, we didn't take into consideration because it passes through the pivot. It passes through the hinge. So according to the formula of F multiplied by the perpendicular distance, well, since the force passes through the hinge, exerted at the hinge, the perpendicular distance would have been 0. That's why we did not consider that in the earlier part of the question. Right, but right now we have to consider it because the question is asking for it. Now, where exactly is this force? Okay, so earlier on we calculated that P is 5 Newton. Well, coming back to the key concept that we are handling today, which is equilibrium. First, we know that the sum of clockwise moment about the pivot, about the hinge, is equals to the sum of anti-clockwise moment about the same hinge. Well, that was okay, we did that earlier. And now we must know that the forces acting on the rod are balanced. So I want you to observe this. So this is the this is the force, this is the rod. All right, this is the rod here, okay? So we're going to take this out, okay, the rod, and we're going to draw the forces acting on the rod. So we have 10 Newton, which is the weight. We have the force of P, and we calculated it to be 5 Newton in the earlier part of the question. Now, does this look like the forces balance themselves? Oh, no. 10 Newton downwards and 5 Newton upwards. Well, something is missing there. So, if the rod is going to remain horizontal, which means it's in equilibrium, all the forces acting on the rod should be balanced, right? So there is actually a force exerted at the hinge right here. Okay, so applying the idea that the rod is in equilibrium and the forces acting on the rod are balanced, so we can say that since there are only upward and downward forces in this case, so keeping it a little bit more simpler, so the upward force must be equals to the downward force. Right, so I'm going to let this force at the, so just by looking at this, we can tell that the force at the hinge would be an upward force. Okay, so therefore the upward force would be F at the hinge plus the force at P will be equals to the downward force. And therefore the force at the hinge will be 5 Newton. So as you can see, we're applying the idea or the key concept that the rod is in equilibrium, so the sum of clockwise moment is equals to the sum of anti-clockwise moment about the same pivot, and also the forces acting on the rod are balanced. Right, so that was the hidden force. I hope you spotted it, and this is really important to understand this chapter. Right, so let's do a very quick summary of what we have done earlier. Number one, we extracted the information from the question. So things like uniform rod, held horizontal, hinge to the wall. These are key information that the question provides. And secondly, we have to make sense of the information. So uniform rod, which means that the CG is at the midpoint, And when they tell you that it's held horizontal, we know the rod is in equilibrium. Hinged tells you where the pivot is. So these are information that you can make sense of in order to make it useful to you in solving the question. And last but not least, we've got to identify the concept that's being used in this question, such as equilibrium and hence principle of moments, so that we can apply it to solve the question. So I hope this is useful to you, and if it is useful to you or someone else might benefit from it, please like, subscribe and share it. Thank you.